Assalamualaikum and hi guys. I would like to continue with our lesson from chapter number 2. This is about how adaptation link with natural selection. Okay, if you look at that, the differential reproductive success or fitness comes about through natural selection. Under a set of environmental conditions, individuals most able to cope are selected for, while vice versa are selected against. Heritable structures and behavioral characteristics that increase fitness are selected. This is about adaptation, and of course this is how adaptation link with the natural selection. Okay, now this is the flow of the event. Okay, natural selection, differential success, survival and reproduction of individual in the population with a given environment. It goes move on into the evolutions, change in any attribute of population over the time, related to genes and allele, leads to adaptation in population over generation, and of course they will adapt with environment with tolerance, adaptation of adaptiveness of organisms. Okay, we look at one by one about law of this adaptation. Number one, we call them as law of minimum living. Okay, according to this law, each resource quantity is minimal, then survival of an organism is minimal. For example, here is plant growth respond to the nutrient that is most limiting. Okay, you just imagine about a plant, once they are providing a source, for example nutrient, for example there are two vase, okay, number 1 and number 2, or A and B. For A1, the vase for A, so we just provide a lot, both of the vases, we provide the same quantity of minimal quantity of nutrient, and we just put for vase A, we just put only 2 or 3 seeds. Okay, meanwhile for the vase B, so we put a lot of seeds. Okay, what happened later on? Of course, A, for vase A, the rate of survival is maximum. Unfortunately for vase number B, they actually compete each other to absorb all the nutrients, so the rate of survival is minimal. So law of minimum living is actually related to vase number B. Okay, this is just another example, law of minimum living. Okay, Liebig compare the potential of a crop to a barrel with staves of unequal length. Okay, the capacity of this barrel is limited by the length of the shortest stave, in this case for example phosphorus, and can only be increased by lengthening the stave. When the stave is lengthened, another one becomes the limiting factors. Okay, so low yield potential. Okay, law number 2 called law of limiting factors by Blackman. This law state about law of limiting factors, which is maximum quantity of a resource tolerated by an organism will be also limit response as well. Okay, for example here, if you look at that, this is about Li of light intensity. Okay, what happened? As the light intensity or Li, okay, through the graph there, okay, increase, the rate of photosynthesis will increase. Okay, until the plant is photosynthesizing as fast as it can. Okay, then after the light saturation point here reach, okay, here if you look at that, this is actually LSP or light saturation point. Okay, what happened here? Plants cannot photosynthesize any faster even when the light gets brighter. So this is called maximum quantity of light that the plant can tolerate. Okay, they cannot tolerate after the point, because that is actually a maximum point for them to absorb all the light intensity. Okay, law number 3 called law of tolerance Shelford's. Okay, what happened here? Laws of tolerance Shelford's combination of Liebig's law of the minimum and Blackman's law of limiting factors. Organisms are constrained by both maximum and minimum extremes of an environmental condition. The response of organism to increased levels of the resource is a bell-shaped curve, with the upper or middle part of the curve representing the optimal state for reproduction of fitness. Okay, we look at figure 7a. So as you can see from here, this is figure 7a. S represent of survival. Okay, here the left one, S. Okay, meanwhile for G is a growth, R reproduction, and O is optimal. Okay, this is quite detailed. Shelford's laws of tolerance is illustrated by a bell-shaped curve. At this bell-shaped curve, there are difference in tolerance for organisms which are zone of the tolerance. Okay, the left this one, zone of tolerance, which is have no organism absent. Okay, zero organism absent. Okay, next is survival. Survival is actually here. Okay, this is a survival area. Then growth. Okay, growth is actually the middle one. This is the greatest growth. Next, greater fitness. Just now, sorry, the growth is the previous one after survival, growth, and greatest fitness. Okay, the maximum peak. Okay, and the last one is the zone of greatest okay, the last one is a greatest fitness. The zone of greatest fitness in area which is the most optimum time for the production of the fitness. So this is actually very important graph for you to understand about each of area, which are from the beginning to your left hand side, zone of tolerance. Okay, which are zone tolerant. Okay, organism absent, followed by survival. The species just only started to survive. Okay, and growth, of course, this is the climax position, because the species now going to grow. And the last one is the greatest fitness. This area or the middle one is actually the greatest reproduction of the species. Okay, and after that the growth narrow down or decrease because of yeah, might be they are old already, and they are this is the time for them to move on. I mean to die, going to die regarding to their age. And of course the graph is like that. Okay, I think that's all for this time of lesson. We continue next time. See you.